were doing yesterday. Okay, so remember, let's kind of bring it back to where we were yesterday before, or just yesterday. Okay, so we talked about this idea of what a vertical asymptote is, right? Okay, how to find a vertical asymptote, whether it has a vertical asymptote, and then how that relates to one-sided limits. So if we're finding remember, one-sided limits always exist, right? They always exist. They might be positive or negative infinity, but they always exist, okay? No matter if you're looking at a picture, like a graph, or if you have an equation. If it's a one-sided limit, it's always going to be something. It's never going to be D and E. Okay, so what we did was, what was the first thing we did when we were doing, when we're algebraically doing any limit problem, what's always the first thing we do?
Plug it in.
Plug it in, right? Plug it in to see what we get. And if we get 0 on top, something on bottom, right? If you get 0 on top, anything on bottom, positive, negative, whatever, what is our answer going to be? 0. Yep. Okay. If we get reverse, something over 0, what is our answer going to be? Or what does that tell us? First of all, what does that tell us about the function?
There's a vertical asymptote.
There's an asymptote, right? So it tells us there's a vertical asymptote, right, at whatever the limiting factor is, right? And then if it's a two-sided limit, not like these guys, just as x approaches 2, what is the limit going to be? D and E, right? But if it's a one-sided limit, we have two options for our answers, right? What's the two options?
Draw a picture.
Draw a picture, right? And then it'll be negative infinity or positive infinity, right? We draw a picture to figure out which one, right? And if we get anything, or if we get 0 over 0, that means keep going, right? That's still the case, right? That's still the case, okay? All right, so the one we left off on was a trig one. I don't think we've talked about trig at all. We do have trig functions, okay? Trig functions still exist. We don't go into trig as much as Math 3 Trig Honors, so we're not going to really go deep inside and go down that rabbit hole.
Isn't pi over 2 like a wave function, or am I thinking of something else?
Cosine, yeah. Cosine's a wave function, yeah. Cosine and sine are wave functions, yeah. Okay, very similar to each other. So yeah, first things first, doesn't matter what type of function it is, plug it in, right? So if I plug in pi over 2, let's see, I'm going to get negative 2 on top, and then I get cosine of pi over 2 on bottom. Oops, no, not that. Okay, so I get negative 2 on top. Cosine of pi over 2. Okay, so remember, if you don't remember from when you did this, cosine's a wave. Cosine function is a wave. Okay, I'm going to give you guys a cheat sheet for all that trig stuff, but I haven't yet, so let's just kind of brainstorm. Okay, so actually, you know what? Let me write this on here. So, what is cosine of 0? What is cosine of 0?
A wave at 0.
It starts at 0, or what is cosine?
1 or negative 1?
1. It's positive 1. It's positive 1. Right? Because if you're thinking about the unit circle, the coordinates at 0, 0 are 1, 0, right? And cosine is x, all the x coordinates. So it would be 1 over, and then on the unit circle, the radius is always 1. So unit circle, right? So at 1, 0, that's the start of the unit circle. cosine's always x, right? Cosine's always the x coordinate. So whatever the x coordinate is over 1, because the radius is always 1 to the edge. Okay, so cosine is 1 over 1, which is 1. Okay? And then as we get closer to 90 degrees or pi over 2, up there is 0, comma 1, right? So cosine would be 0 over 1. 0 over 1 is 0. So at pi over 2, cosine is 0, right? And that's it's the start of the wave. So the cosine wave goes like that, and then eventually it will come back up. At 2 pi, right? And then at pi, it's negative 1. At 3 pi over 2, it's 0. And then at 2 pi, it's 1. Okay? So we want pi over 2. So cosine of pi over 2 is 0. Okay? So when we plug in 2, or sorry, pi over 2, we got 0 on the bottom. So what does that tell us? Before we go into our next steps, what does that tell us? There's a vertical asymptote at that value. So there's a vertical asymptote at x equals pi over 2. Okay? So let's draw a picture. Let's draw a picture of this is what cosine looks like. We're going to draw a picture of what negative 2 divided by cosine looks like. Okay? So let me give me some more room here. All right, so we got positive 1. No, let's not do that. Okay, so at pi over 2, we have a vertical asymptote. And then 3 pi over 2 and 2 pi. Okay, so let's draw that. Okay. Okay, so what side are we going to focus on? The right side or the left side? The right side, just this side over here. Don't care what happens on the left side because that's the negative side. We're on the positive side. Okay, so what I'm going to do is I'm going to plug in values that are closer and closer to pi over 2 and see if it's in, because remember, our two answers are going to be either positive infinity or negative infinity. Okay, we're down to those two. We just got to figure out which one it is. Okay, so let's start at 3 pi over 2. 3 pi over 2, and then we'll go pi. Okay, so we're going to plug it into the original equation, which is, let me highlight it in yellow. This guy right here. That's the original. We're going to plug it into the original and see where it's at. Because coming from this way, we know it's either going to hug up positive infinity y value or it's going to hug down negative infinity y value. It's only got two options. Can't go through. Can't go through. Okay. So if I plug in, let me plug in 3 pi over 2 for the original. So I get negative 2 over cosine of 3 pi over 2. Okay. Always negative 2 on top for this guy. So what is cosine of 3 pi over 2? 0, right? Look at the graph. It's 0. 3 pi over 2, the y value is 0. So that means we have another asymptote there. We don't really care about that asymptote, but it's good to know. Okay. So it's looking like every pi, it has an asymptote. Not really important, but that's just something to know. Okay, so here we go. Let's try pi now. Let's try plugging in pi. Negative 2 over cosine of pi. So negative 2 over, what do we get? What's cosine of pi? -1, yeah, -1. So a negative divided by negative makes a +2. So I'm going to go make that dot. So at pi, we got a -2. Or +2, sorry. By one dot, I can't tell if it's increasing or decreasing. I can't tell if that dot, it could increase or decrease. I have no idea. From there, it could go up, or from there, it could go down. So I need to pick another value that's in between, kind of in between, right? Any value in between, any value in between. Pi over 4. So pi over 4 is actually less than pi over 2. So pi over 4, so this is where we're at right now. So I'm over here, let's see, no. I need to pick a value between here and here. So so let's see, pi, that's pi over 2. Let's see, what's halfway in between pi over 2? Well, think of this. Think about pi over 2 is what? What's in front of the pi? 1. Isn't that 1 over 2?
Yeah.
And then what is pi? Just one whole, right? Yeah. So what numbers, what fractions, what common fractions are between there?
3 pi over 4.
3/4, right? So let's do 3 pi over 4.
Oh, cool.
Sometimes if you just take away the pi's, you can get there, okay? Because 1/2, 1, in between, right? So 3 pi over 4.
So what you're saying is I shouldn't have burned my notebook from yesterday.
No, I'll get you guys.
It's good fire starter.
So I will get you guys. I haven't yet. I don't know why, but last year, every year I give students a. Let me see if I can show you a cheat sheet for this stuff, so you don't have to memorize or remember all of that stuff. Let's see, where is it? I'll let you use it on quizzes, not tests. Okay.
So this is a calculus with trig functions.
What's that? There's trig. We deal with trig in calculus. Not a lot, but we do deal with trig. We deal with all the functions. All the functions you guys did in Math 3, we'll see again. Okay? We're just talking about limits, derivatives, and integrals with them.
I should have kept that.
Okay? So I'll get you guys a copy of this. Okay? Oops, nope, don't want that. Okay, here we go. Let's go back to this now. Okay. So we got 3 pi over 2. Or wait, we said 3 pi over 4, right?
Yeah.
So cosine, so let's plug it in. -2 over cosine 3 pi over 4. Well, looking at the graph, is it going to be negative or positive? Negative. It's going to be negative. Because in between half pi and a full pi is 3 pi over 2, right? Or 3 pi over 4. And the y value is negative. So it's going to be negative. We know it's going to be negative, right? We just need to know, actually that's enough to give us our answer. Because if we get a negative on top and a negative on bottom, that's going to be a positive answer, right? Okay, so that tells us, actually 3 pi, let's see, 3 pi over 2, 3 pi over 4, let's see, is negative root 2 over 2, negative root 2 over 2. So I don't want to get stuck in the weeds with all that stuff. We're just trying to find a limit here. I don't want to get too bogged down with trig, okay? So yeah, so when you do that, you'll find out that I am increasing here. I am increasing here. Therefore, the limit as x approaches pi over 2 from the right is positive infinity. Okay. I'm not interested in going too deep into trig. We only deal with the trig that we absolutely need to deal with. We don't, like, in Math 3 trig honors, sometimes you deal with trig that's not necessary. It's just trig for the sake of trig. In this class, we deal with trig when we need to deal with trig. When we don't need to deal with it, we put it to the side. Okay? All right. Okay, so now I'm going to give you a couple more practice problems, just like this, to see what you can. We'll call this, that last one was E, we'll call it F. Okay, let's see here. So I'm going to ask you two things. I'm going to say, give me vertical asymptote, and then 2, find the limits. So for all these problems, that's what I'm going to ask you to do. Does it have vertical asymptote? And if it does, where? And then find the limit. Okay, let's see. Let's see here. First one. The limit as x approaches 3 from the right, 2 over x minus 3 squared. Do that one first. For vertical asymptotes, you set the bottom equal to 0. You're going to get 3. Okay, so it's a vertical asymptote at 3. And then we're going to find the limit as x approaches 3 from the right. So we focus on the right. So if I plug in 5, I get 1/2 to the original equation, to the original guy. If I plug in 4, I get positive 2. So as I'm getting closer and closer to 3, x equals 3, the y's are going up. So that means it has to be positive infinity. Okay? Positive infinity. Okay? All right, let's try this one. Oh, we got plenty of time. Let's see. Yep.
If I were to plug in 3 to find a vertical asymptote, would that work as well? Or is it only, can I only do it that way?
So if you plug in 3, you'll get a vertical asymptote, right? Oh, yeah. Without solving, you're talking about?
Yeah.
Yeah. That'll work. All right, let's try this one.
I haven't tried, but maybe it's
So I'm going to try to give you different things that look different, but they're really not. Okay, so that's the key to understanding. If I can give you something that looks different, but you can put your head around it, it's really not. Here we go. Same thing. Vertical asymptotes and find the limit. Okay, so here we go. The limit as x approaches 0 from the right again. And here's the function, 6 minus 1 over x cubed. Okay. Okay.
Oh, yeah, I just realized that.
Or do you just subtract? Wait, what?
It's a zero, so
It's one over.
it's one over here, so it's just six.
Wait, what? So you got 6 points?
Yeah, I do one over 0.
Because only.
Oh, we could win the league.
What?
We are, yeah, we're only winning from the race.
I
I got 6 over 1 minus 1 over 16.
Guys,
What?
I think we're over college.
So then,
Yeah.
Zero.
I have a question.
Mm-hmm.
So can we use that same equation when we're plugging in, like,
Zero.
when we're making our table for
Yep.
graph?
Mm-hmm. They're both exactly the same, so you could use one or the other, yeah. Mm-hmm. Whichever you're more comfortable using.
6 times 0 is 0. No, but low. You're solving for this one. Yeah, the bottom is 0. So you get very fast until negative 1. But you
6 times
don't
1.
worry about the numerator when you're finding the very fast. Oh,
That's why I said, that's why I thought the verbal active was just 1.
why would it just be
Why would it be negative?
So if it was 0, I'm gonna just say negative 1.
What?
Equals 0.
Because
Oh, you're right, the verbal active is 0.
Yeah.
What? Yeah, the verbal active is 0.
Oh.
So vertical asymptote is at 0.
Boom.
Okay.
Mic drop.
So each of those yellow circles, it's exactly the same. It's exactly the same. It's like saying, so it's kind of like saying this was, let me give you a better example. Instead of saying 6 minus 1/2, you say 5 2/3. Those are the same thing, or not 2/3,
The square root?
1/2,
But he's getting rid of the cube.
all right? Those both are the same thing.
Like 0 cubed.
So if you're more comfortable using this, the subtraction one, go for it. If you're more comfortable actually subtracting them, that's what the answer is, okay? That's what it looks like that way. So whichever way you're more comfortable with, you're going to get the same answer for both. So there's an asymptote at 0, okay? So we got to figure out what's happening to the right of 0. Okay, so if there's a vertical asymptote at 0, it's going to go along the y-axis. Okay. All right, so then we go 1, 2, and then we see what is going on here.
I got negative.
So we got 2, we get 1. Let's see what's going on. Again, you don't have to use both. You can use one or the other. So if you use the first one, if you use the original one, you would get 6 minus 1 over 2 cubed, which is 6 minus 1/8, which is 5 7/8. So 1, 2, 3, 4, 5, almost 6. So it's 5, almost 6.
Negative infinity.
And then if you go 6 minus 1 over 1 cubed, that's just 6 minus 1. 5. So it is decreasing slightly.
Wait, Mr. Flores.
Uh-huh.
How did you get 2 cubed, like in the equation?
2 cubed?
Yeah.
Because I plugged in 2, right? I plugged in 2 here. I plugged it into the original.
My bad.
You could plug it in there too. You would still get 8 on the bottom. It doesn't matter which one you plug it into. Okay?
My bad.
No, you're good. You're good. That's a good question. If you're not clear, it's a good question. Okay? No need to worry about, that, because for sure we want to keep this clear. Okay? So it's negative infinity, right? So that was the wrench. Let me ask you, what was the wrench in this problem that was different than the other? Like I said, when I say different, I mean different looking.
The 6 minus.
Yeah, this guy here, right? That was the wrench. Everything else was the same, and that's all this is. It's just different functions work differently, okay? Trig, but you're doing the same thing. It's just trig, right? Once you can get past the trig stuff, it's just the limits that we're working with, okay? All right, let's try another one. Let's call this one H. Let's see. Give you. Let's try another trig one. Okay, here we go. The limit as x approaches 0 from the right, 2 over sine x. 2 over sine x.
I don't remember this one. Wait, is it opposite cosine now?
Yes.
So it's just like, instead of that.
It would be going up. It goes up the y-axis. Stop.
Wait, no, because it's opposite cosine, isn't it? So it's this right from this right. Wouldn't it just be 2 and 0? I don't know. Because the asymptote.
Yeah, it would be 2 over 6.
Sine of 0.
I don't even know it's thought.
You gonna see the new Dune movie for us?
The new what?
The Dune movie, part 3?
I probably will. In Christmas time, right?
I think so. I keep on falling asleep after watching like part 2. Like,
It's long.
The beginning is so slow.
Yeah.
Oh, wait.
It is pretty slow.
What's your course?
Yes.
Does this sine graph just flip from the cosine graph?
It's not.
Or it's like, it's like,
Part 1 and 2.
I don't know, I watched the whole thing.
It is inverted. Yeah, you're right. It is inverted.
Okay,
It starts at 0. Yeah.
so
Part 2 was.
it would be 1 at pi over 2.
If you ever read the books, it's so.
Yeah.
Okay.
Yep. And then falls after that, and it goes back up. Plug in 0.
We were approaching
Plug in 0, and why is this not even? There we go. Plug in 0, you get 2 over 0 because sine is 0, 0. Okay? Vertical asymptote. And then you can set sine equal to 0 and figure out where the sine equals 0. It equals 0 at 0.
Wait a minute.
We can't do that as an asymptote.
Okay, vertical asymptote. All right, so let's draw a little picture here.
No, it doesn't, it's on the positive side.
Yeah, so wait, why is that this one?
Okay, here we go. So pi over 2, pi.
Isn't it better just ignore everything that's on the other side?
Yeah, no, we're only looking at this side, because there's nothing on this side. On this side.
So let's see what we get. We get x, so we get pi over 2. So 2 over sine of pi. Let's see, sine at pi is 0. So you get 2 over 0. So that means there's there's a lot of asymptotes in trig graphs. Again, we don't really care, but we'll note it, okay? So then pi over 2. So you get 2 over sine of pi over 2. So that's an actual number because pi over 2, it's 1. Pi over 2, the value is 1. So you get 2 over 1. 2. So we got to do an in-between again because I need another point of reference. I don't know from that point, I can't tell if it's going up or down, if it's as it's going that way. So in between, again, in between 0 and 1/2, 1/4, 1/3. Yeah, 1/4, 1/3, 1/6, all of those guys. Okay? So I'm going to try 1/4, right smack dab in between. Pi over 4. Pi over 4. So I get 2 over sine of pi over 4. So I get 2 over, let's say we don't remember. Pi over 4 is halfway in between 0 and 2 pi. 1/4 is halfway in between 0 and 1/2. Okay? So again, it's like halfway, so it's like right about there. So it's positive. It is positive. And it's going to be, so it's going to be, if you had to put a fraction on it, if you had to put like a guess on it, is it going to be bigger than 1 or less than 1? Right there, right? It's right there. It's less than 1, right?
Oh, I'm
So what is, it's square root of 2 over 2. It's square root of 2 over 2, but I don't want to mess with square roots right now. What is, if I have a, what's the easiest way to say this? If I have a fraction on the bottom, what does that really do? What does the bottom of a division problem do? As the bottom gets bigger, how does it affect the whole value?
Makes it smaller.
Makes it smaller, right? As that number gets bigger and bigger and bigger and bigger and bigger and bigger and bigger, the whole thing is going to become smaller, right? Now let's say, let's pick a small number. Let's go the other way and say the smaller, as I put a smaller number in here, well, how is that going to affect the whole thing? It's going to get bigger than 2, right? It's going to get bigger than 2. So that means it's going to increase. Okay? Okay, so think of numbers. Pick a fraction. Pick a fraction. Write a fraction down on your paper. Write a fraction down on your paper. Any fraction. Any fraction you want. Put a fraction. Make it easy. Make it as easy as possible. I'm going to say 1/4. Okay. So as I change 4, so now I'm changing 4, and I'm getting bigger. 10. 100. Right? I'm getting bigger, right? What is happening to the original number, 1/4? Is it getting bigger or smaller? A lot smaller, right? So doesn't it make sense that if I go the opposite direction, what's happening to the original number? Is it getting bigger or smaller? That's what I was saying. That's all. That's exactly what I was saying. So instead of having to crunch numbers, if you know about, this is called number theory, if you know how numbers work, you can kind of get around doing all that work. Because I know in math, a lot of times you're like, what's the answer? We got to find the answer. Sometimes that's not the most important question. Sometimes the most important question is, what's going on? What's that doing? So so let's get back to this. So what I'm saying is, since this number, we said sine of pi over 4, is a fraction, right? That's less than 1. It's smaller than 1. Isn't a fraction a small number? So it's doing this. It's making the entire fraction bigger. Okay? As I get smaller on the bottom, the fraction is getting bigger overall. That's what I was trying to say. Okay? So before, it was just a plain old 1, right? What if I put a fraction down here? Is a fraction bigger or smaller than 1? Smaller, right? So we went from having 1 on the bottom to something smaller. Is that going to make the entire thing bigger or smaller? Bigger. So it's going to be bigger than the answer I got here. So we're going up. So it's increasing. Okay, it's increasing. Okay? All right. Yes?
I understand like that part.
Yeah.
But how does it tie into that? I still don't get
was it?
Excuse me. So we got 2 over 1, right? We had 2 over 1? Make 2. So if I were to put a number bigger than 1, would it still be 2? It would be what? Smaller than 2, right? Okay. So if I put a number, let's go the other way. If I put a number smaller than 1, wouldn't it go up? That's what I'm saying, yeah. So it's going to be bigger than 2. That's all I'm saying. Yeah. A concept you guys have known since elementary school when you did division, but it's a little bit weird when you see it in calculus, that's all.
So like, I mean, this is probably dumb, this is definitely a dumb question, but where did we get all like the pi and stuff from?
The pi.
Like all the pi's in this problem.
Oh, because we're approaching 0, right?
Like, why don't we just draw like a regular graph that has like 1, 2?
Because it's a trig graph, so trig graphs have pi's on them. If it was a regular function, polynomial, any of the other ones that we've done, it pretty much if it's anything else other than trig, we'll draw a regular graph.
So like when it has sine, cosine or stuff, then we have to put the
Yeah.
pi's in there.
And you rarely have to do graphs. I'm telling you right now. This section, especially when we're dealing with one-sided limits, is a lot of thinking. Because you have to try to picture it in your head. Okay? Not everything is going to be this hard. Okay? Some people enjoy it. Some people enjoy doing that math in their head. Some people are like, you know what? I'd rather put it on paper. I'm like that. Okay? So sometimes it's harder to visualize it than not, right? So this is very visual. That's why we drew graphs. Will we draw graphs the rest of the chapter? No. No. Okay, so just stay with me. I know this is a little foreign, but just stay with me. You guys are all right. Okay? That's why tomorrow all we're going to do is the practice. I'm going to give you the practice assignment so that you guys can work on it, check your answers, ask for help if you need it. Okay? So that we're sure before we move on. Okay? All right. Okay. All right. All right, guys, we've got about 3 minutes. Yeah, like I said, all we're doing tomorrow is just doing the practice, working on the practice. We'll pause for the notes. Since it's Friday, we'll pause for the notes and we'll work on practice 3. Okay? All right. Yes, sir?
So in a trig graph, it basically replaces, well, so let's say just say pi is basically a trig graph's 1. And then